Good morning to all. Myself Ovik Roy, your mathematics teacher from the Mathematics Icon channel. And in this channel, various types of discussions from the different chapters were being discussed, and the various lectures were given in my channel. Just you can see, and if you subscribe to my channel, then you can see the lot of videos are being uploaded regarding the JEE main and advanced classes, and then 11th regular classes and the 12th regular classes as well. And very soon, just I am going to start the 9th and 10th level mathematics in my channel as well. Just those who are very much interested to join the classes as well, then they can join the class. Okay, so very good morning to all my students and my subscribers and my viewers as well, and thank you very much for your support and for your loving support. Okay, so today just we are going to discuss the very important concept, and the very conceptual also, the differentiation chapter. Okay, so as you all know, the differentiation from the differentiability chapter, the differentiation concept were discovered. Okay, so actually this differentiation, what do you mean by the differentiation word? So what do you mean by the differentiation word? Differentiation means if a work is continuing incessantly, okay, then actually this the rate of changes, the values, okay, with respect to time or with respect to something is called the differentiation. That means the rate of some works, the rate of speed, okay, that means in which speed the values of the outcomes is changing with respect to the input values, okay, is called the differentiation. If I take an example here, the speed, dx by dt. So how can I express this speed here? Displacement, if I denote the displacement as x, okay, so this displacement is changing, that means the distance is changing. Distance is changing with respect to time. Okay, so distance is changing. If I denote the distance as x, so distance is changing, that means there must be the difference between the values of the distances as well. Okay, अगर यहाँ पर distance change हो रहा है, that means distance में changes आ रहा है कि नहीं? तो ये changes आ रहा है, that means differences आ रहा है. Difference को हम लोग denote करते हैं d से, d. So d किसका difference आ रहा है? x का. तो d of x divided by किसके रेस्पेक्ट में ये डिफरेंस, ये डिस्टेंस चेंज हो रहा है? टाइम के रेस्पेक्ट में. दैट मीन्स टाइम जितना चेंज हो रहा है उतना ही डिस्टेंस भी चेंज हो रहा है. दैट मीन्स नीचे जो है वो टाइम का डिफरेंसेस रहेगा. दैट मीन्स डी ऑफ टी. Okay, so that means dx by dt, here it is the rate of change of the displacements. Okay, and I think in the physics subject, this thing can be explained as the speed of some function, okay, of some works, okay, the rate of change of the displacement. Okay, so here everywhere, just if you want to find the rate of something, then the differentiation will be used. Without the differentiation you can't find the rate of changes. Okay, rate of changes of any function of any works. Okay, so this differentiation word everywhere that you can see, that means here I am talking, here I am talking, my talking speed, my conversation speed is also a differentiation. With respect to time, my speed is 10 km per hour. Okay, so that means dx by dt. ओके, तो दैट मीन्स यहाँ पर ये जो कोई भी रेट तुम यहाँ पर बोलना चाह रहे हो, कितना स्पीड से तुम खा रहे हो, स्पीड आ गया, दैट मीन्स यहाँ पर डिफरेंशिएशन आ गया, है कि नहीं? फिर उसके बाद सपोज मैं यहाँ पर सपोज एक फोर्स दे रहा हूँ, फोर्स देके एक को धक्का मारा, ठीक है? धक्का मारने के बाद ये जो फोर्स में जितना ज्यादा यूज करूंगा उतना ही वो दूर जाके गिरेगा, है कि नहीं? तो दैट मीन्स ये जो फोर्स मैं जितना ज्यादा दे रहा हूँ उतना ही वो दूर जाके गिरेगा. दैट मीन्स जितना मैं ज्यादा इनपुट दे रहा हूं उतना ही वो दूर जाके गिरेगा. दैट मीन्स आउटपुट भी ज्यादा होगा. दैट मीन्स दिस आउटपुट, दिस डिस्प्लेसमेंट ऑफ द नॉक्ड पर्सन इज डिपेंड ऑन द इनपुट वैल्यूज. इनपुट वैल्यूज दिस, दैट मीन्स दिस पुशिंग. Okay, that means if you pushed more, then his displacement will be more. So this rate of displacement can also be denoted by the differentiation as well, dx by dt. Okay, here dt means what? With respect to time, here actually this time is not accepted here because I am giving the input. Okay, so that my force will be the input and the output will be what? His displacement. Okay, so this means you can choose any two variables for these two things. My force x, okay, x, and this his displacement is y. Okay, so that means his displacement dy with respect to my force, that means dx. So that means dy by dx. So that means everywhere that you can see that everywhere the differentiation concept is included, is involved. Okay, so here we are discussing about the differentiation chapter in the differentiability concept in the first lecture. Just I think if you are not viewing the lectures, the previous lectures, that means from the differentiability part, if you are not actually seeing the previous lectures, then you will not get the idea what is the differentiation here. Okay, that means suddenly just if you are looking the differentiation chapter, then I think you will not get the idea how to solve and from where these differentiation concepts were introduced. Okay, just because this differentiability is the base of the differentiation. Without the differentiability means what? A condition, a property by which you can prove that a function is differentiable. If a function is differentiable, then you can find the differentiation as well. Okay, so that means if you want to check whether it is differentiable or not, then the differentiability condition should have been known for everyone. Okay, so here the differentiation comes from where the differentiability concept, the first principle of the differentiation. In the first lecture of the differentiability, you can see that the differentiability concept were discussed also. Okay, so just if you see the differentiability, the whole chapters, then the differentiation should be continued here. Okay, so this is the chain actually, and with with one chapter, the another chapter is linked. Okay, so just if you are not actually just getting the idea about the differentiability, then you will not get the idea about the differentiation as well. Okay, so if you like my lectures and if you like my videos and my level, okay, just please subscribe, like and share my channel so that I can provide the various lectures and various things regarding the various chapters or various topics from the mathematics subjects as well. All the chapters and all the concepts will be given to each and every students, and each and every materials, various materials will be provided also. Actually this classes is going on, and in this classes just I am discussing various lot of questions, okay, from the different chapters as well. And the first in the first session actually the relation function chapter was completed, and now this calculus part is going on. So after this calculus part, every chapter will be discussed, every chapters will be discussed. Okay, so one by one. Okay, so because I started this differentiation chapter, this calculus part, because in the physics and the chemistry subject this calculus part will be used more. So that's why you should have the concept, you should have the knowledge how to differentiate a function. Okay, so without knowing the differentiation, that you can't derive the physics derivation. Different types of derivations are there in the physics subject. So if you don't know how to differentiate, then I think this in the physics you may face various kinds of problems regarding the derivations from the different concepts as well. So that's why just I have started the differentiation, the calculus part. So we are continuing the differentiation here. Okay, so now actually in this differentiation chapter, differentiation, okay, differentiation, okay. So differentiation, let us take fx be any real valued function. Okay, fx be any real valued function. Real valued function means all the inputs and all the outputs will be from the real numbers. Okay, not from the complex numbers, not from the imaginary numbers. All the real field, that means all the real values will have to be chosen for getting the differentiability concept as well. Okay, so here just if the values of x is changing with respect to something, okay, so here just you can see input values will be x, output values will be what? F of x. So that means here output values is changing, is changing with respect to what? Input values. Okay, so that means here the output values is depend on the input values. Okay, so that means which part is dependent, part on the other function, that part should be in the numerator part and the other part will be in the denominator part. Just remember this thing. So here differentiation can be expressed as, here fx is changing with respect to x is changing. Am I right? fx चेंज हो रहा है, आउटपुट चेंज हो रहा है जितना तुम इनपुट चेंज कर रहे हो. दैट मीन्स ये जो चेंजिंग आ रहा है, दैट मीन्स ये चेंजिंग वर्ड, दैट मीन्स द differences between the values of fx here. Okay, so that means here differences, this word can be expressed as d किसका value? fx. The value of fx is changing with respect to changing of the x value. That means d of x. So that means this line can be written as ddx of fx. This part can be exclaimed as ddx, just like that, ddx of fx. So shortly, just you can express this ddx of fx like f dash x. So that means if you want to differentiate a particular function, then you, with respect to something, then you have to use this differential coefficient, that means ddx. Every time that you should you should take the differentiation with respect to x, it is not actually the same thing. Okay, so in various questions, various types of input values will be there. Okay, so here just I am taking the input values as x, and that's why we are taking ddx. Maybe the input values will be y is changing, then ddy will be there, ddy. Z is changing, that means ddz will be there. Okay, it depends on the question. Okay, it depends on the various types of functions in which respect that means the function, the input values, the output values is changing. The output values depends on the input values as well. So that's why whatever the input values will be given in the question, you should take the same. Okay, so here ddx of fx means f dash x, that can be written. Okay, so now in the differentiation chapter, actually this in the differentiability part, in our last lectures and last two lectures, we have derived a lot of questions, ddx of this, ddx of this, ddx of this, using first principle. Actually those are all the formulas as well. Okay, सब formulas होता है, वो सब formulas आप लोगों को एक list करके लिखना है. Just write the line formulas. Just write formulas. 1. ddx of sin x equals to cos x, ddx of cos x equals to minus sin x, ddx of log x equals to 1 by x, ddx of e to the power x equals to e to the power x, ddx of a to the power x equals to a to the power x log ea, ddx of tan x equals to sec square x, ddx of cot x equals to minus cosec square x, ddx of sec x equals to sec x tan x, ddx of cosec x equals to minus cosec x cot x, ddx of okay बाकी है, ddx of sin inverse x equals to 1 by root over 1 minus x square, ddx of cos inverse x equals to minus of 1 by root over 1 minus x square, ddx of tan inverse x equals to 1 by 1 plus x square, ddx of cot inverse x equals to minus of 1 by 1 plus x square, ddx of sec inverse x equals to 1 by mod x root over x square minus 1, ddx of cosec inverse x cosec inverse x equals to minus 1 by mod root over x square minus 1. So these are the formulas. Okay, these are the formulas. All the formulas are written in this board. Just you can make a list for all the formulas. Okay. Okay. Now, then the another formula is ddx of x to the power n equals to n x to the power n minus 1. N x to the power n minus 1. This is the formulas actually from the differentiation chapter. Different types of formulas are there. Just you have to remember the formulas as well. And two special type formulas are also there. Special type formulas. Okay. Two special type formulas are also there when the two different functions just write the formulas here. Okay, just you will get these formulas in the various books also. In every book these formulas are available. Okay, so if two functions are in the multiplication form, then ddx of u and b. U is one function, b is another function. Okay, so ub equals to u into ddx of b plus b into ddx of u. Okay, this is the first one. And the second one is, this is the multiplication form. No, so second part will be in the division form. If two functions are in division form, then ddx of u by b equals to b square b into ddx of u minus u into ddx of b. Here u and b are the two different functions as well. Okay, just u and b values will be dependent on the given question actually. Okay, just whenever you will see that the different functions are in the multiplication form, then you have to use ddx of u into b, and if the functions will be in the division form, then you have to use ddx of u by b as well. Okay, so concisely that we can see that the differentiation of any functions, it may be the different functions as well. Just you can see everywhere the functions are changed. Just you can see the formulas here. In everywhere the different functions are given, but the ddx, that means the differentiation of that particular functions, will be given in the various forms. Okay, and that can be proved also by using the first principles. All the formulas can be proved, okay, by using the first principle, because the differentiation came from the differentiability concept. That means whatever the formulas and whatever the concepts that you are getting from the differentiation chapter, all are from the differentiability concept actually. Okay, just all the things and all the concepts can be proved or can be actually verified by the differentiability chapter as well, by using the first principle. Okay, so here just let us move to some questions as well, that I think after solving the questions you will get the idea how to differentiate something. Okay, now just write the question. Differentiate log sin x. Differentiate log sin x with respect to differentiate log sin x. Okay, by using first principle. Differentiate log sin x by using first principle. Just let us check how to differentiate one function with respect to the first principle. Okay, just we will solve this particular questions in two process. First one is for the first principle, and second one that direct process. Okay, just we will solve. Okay, now the first process, just you can see fx equals to what? Log sin x. Okay, then now you have to use the first principle. That's why f of x plus h equals to log sin x plus h should be written. Now the first principal formula, as you all know, the first principal formula is f dash x, h tends to 0, f of x plus h minus f of x by h. That means limit h tends to 0, f of x plus h log sine x plus h minus log sine x whole by h. Now limit h tends to 0, log a minus log b, log a minus log b, that means log a by b can be written. Okay, this is the formula actually from the logarithmic expression. So log sine x plus h by sine x whole by h is there. Okay, so do you have any kind of formulas regarding the log expression in the limit? Yes, we have. Just write the formula. Limit x tends to 0, log 1 plus x by x equals to 1. This is the formula. So without using this formula, we can't solve this logarithmic expression differentiation. We have to use, anyhow, just we have to use this formula as well. Okay, so we are bound to use this logarithmic formula here. We are bound. Okay, anyhow, we have to use the formula. Anyhow, we have to use the formula as well. Okay, so here you can see in the logarithmic expression formula, just you can compare with the formula. You can compare the given expression with the formula. Okay, just you can see with the logarithmic expression 1 plus x, that means 1 plus should be there, 1 plus should be there, but there is no 1 plus in this expression. Is there any expression like 1 plus something? So where from you get this 1 here? We have to introduce forcefully, just we have to introduce this plus 1 by introducing the minus 1 as well, because we have to neutralize the plus 1 as well. Okay, just we can't do anything whatever we want in the mathematical expressions. Okay, just if you are introducing something, if you are introducing some numbers here, just you have to neutralize the particular number as well. If you are introducing the plus 1, then you have to use the minus 1 with that expression as well. Okay, so now limit h tends to 0, log sine x plus h by sine x. Okay, minus 1 plus 1 can I use? By h is also there, minus 1 plus 1, right? Can I use this thing? Now in the next line, limit h tends to 0. Here you can see log 1 plus x, 1 plus x, this. Okay, so I think if you compare this expression with this part, so then you can see in place of x, which term is there? This term is there. That means in place of x, this term is replaced by this sine x plus h by sine x and then minus 1. So that means this same term should be introduced in the denominator part also. Okay, that means without introducing this part in the denominator part, you can't use the formula here, because according to this given formula, log 1 plus x by x, that means whatever the term is there in the place of this x, that the same term should be repeated in the denominator part as well. That you can see the log x, this is your x, plus 1 by x. So where is your x here? So we have to introduce again. Okay, so just if you are introducing this x part in this place, then you have to rationalize, neutralize this part. Okay, so here, how can I neutralize here? Just you can see the process. Limit h tends to 0, log this sine x plus h by sine x minus 1 plus 1 by h into this sine x plus h by sine x minus 1. Now we have introduced this part. So if I introducing this part in the denominator part, the same term should be introduced in the numerator part also. That means sine x plus h by sine x minus 1 as well. Okay, So just means if you are introducing something in the denominator part, the same term should be repeated in the numerator part as well, just for the neutralization. Okay, so here we can see limit h tends to 0. Now if you compare the formula, that you can see this part is 1, log 1 plus x by x equals to 1. We can write directly by using the formula. So which term is left here? Sine x plus h by sine x minus 1 by h by h. Okay, so now limit h tends to 0. In the numerator part, if I take the LCM, sine x plus h minus 1, minus sine x by h, there is limit h tends to 0, sine x plus h minus sine x by h into sine x. Am I right? So here we can see in the denominator part, one sine x is there. So sine x is not h related term. So we can actually throw it out from the limit expression as well. So if any expression is involved in the limit part, but the no expression is given in this expression in this part regarding h, then this. So if you have any term, any other term regarding any other variable except h, then that term should be towed away from the limit expression as well. Okay, so just यहाँ पर देखो ये sin x डिनोमिनेटर में है, इसमें h रिलेटेड कुछ भी नहीं है. So that means ये लिमिट के अंदर रखना जो है वो क्या होगा, नाइंसाफी होगा. So that means limit h tends to 0, sin x plus h minus sin x by h is there. Okay, so this expression, I think we already solved this type of expressions just in the differentiability chapter. Okay, whenever just we solved this, I think ddx of sin x we solved by using first principle. ddx of sin x, we solved this part, I think. So ddx of sin x, if you use the first principle here, limit h tends to 0, sin x plus h minus sin x by h equals to, what was the answer? Cos x. वो निकला था आंसर, है कि नहीं? वो निकला था आंसर. तो यहाँ पर आपको ये जो पार्ट दिखाई दे रहा है, इसको आप क्या लिख सकते हैं? 1 by sin x into cos x. So that means cot x is the answer of this given question. But in the exam, you should not write this like that. Okay, just you have to solve this whole part. You have to solve the whole part here, because we already solved this question, this ddx of sin x, and that's why we remembered the form, remember the answer, and that's why just it is already used in the given expression as well, and that's why actually just. But in the exam hall, you have to solve everything. Okay, just whether you know or not, just you have to solve the differentiation of any particular question. Okay, fully. Then the full marks will be given. Just if you are using directly ddx of this part is cos x, then I think the half mark and 1 mark may be cut. Okay, so actually this cot x is the answer. Okay, now in the next question, just write the next question here. ddx of sine inverse twice x plus 3. Sine inverse twice x plus 3. This is the next question as well. Okay, so here fx is what? Sine inverse. Fx is sine inverse twice x plus 3. So f of x plus h is sine inverse 2 into x plus h plus 3. In place of x, just you have to use the x plus h here. If f of x is twice x plus 3, then f of x plus h will be what? In place of x, you should put the x plus h here. So just we did the same. So if I use the first principle, limit h tends to 0, f of x plus h minus f of x by h. So that means limit h tends to 0 sine inverse 2 into x plus h plus 3 minus sine inverse twice x plus 3 whole by h. This is the expression actually. Okay. So as I told you in our last video that we already solved this type of question, that means sine inverse x minus sine inverse y. There is a formula actually. Okay. So sine inverse x root over 1 minus y square plus y into root over 1 minus x square. Just you can see the formula here. Okay, so that means यहाँ पर देखो sine inverse x, this is your x and this is your y. So that means limit h tends to 0 sine inverse, just compare with this formula, x into, what is your x here? 2 into x plus h plus 3. Okay, x into root over 1 minus twice x plus 3 whole square. Then this will be minus, this will be minus, then minus minus twice x plus 3, then root over 1 minus twice x 2 into x plus h plus 3 whole square. So this is the whole formula actually, very long expression it is. Okay, so no need to be scared about that. Okay, so just whenever just you are getting this long expression, some students actually they are supposed to be very much confused. Okay, so no need to be confused here. So just if you are getting this long expression, then just actually this just keep your mind fresh as actually as like a cucumber. Okay, just cool like a cucumber. Okay, so just keep this thing in your mind whenever just you are getting the long expression, then no need to be scared about that. Just you have to solve in the formal ways. Okay, whatever you know about the concepts and about the actually this algorithm and the steps, just you should use that algorithm also. Just as you all know, sine inverse x, this x part is the bigger part actually. Okay, sine inverse x, this whole part is x. Okay, so sine inverse x by x equals to 1. Limit x tends to 0, sine inverse x by x equals to 1. This formula is known, I think. Okay, so if you have the sine expression, sine inverse x expression, then this x should be repeated in the denominator part as well. But we don't have this same expression in the denominator. Just you can see. That means we need to introduce this x part in the denominator part. Okay, so here this calculation, it may be lengthy, but don't be scared. I am here. So limit h tends to 0 sine inverse 2 into x plus h plus 3 root over 1 minus twice x plus 3 whole square. Okay, and then minus twice x plus 3 root over 1 minus 2 into x plus h plus 3 whole square. Whole divided by h is there. So that means sine inverse x, this whole part should be introduced in the denominator part as well. So just introduce it. 2 into x plus h plus 3, then root over 1 minus twice x plus 3 whole square. Okay, then minus twice x plus 3 and then root 1 minus 2 into x plus h plus 3 whole square. So this same term should be introduced in the numerator part as well for the neutralization. Right? We are bound to introduce this thing. So that means 2 into x plus h. I am writing this because there is no space. That's why just I am writing in this place. Okay. So this root over 1 minus twice x whole square, then minus twice x plus 3 and then root 1 minus 2 into x plus h plus 3 whole square. Okay. So according to the formula that you can see, this whole part is 1. Limit x tends to 0, sine inverse x by x equals to 1. Whatever the x it is, no need to consider this thing. If you have this expression like the formula, then you should use the 1 as well. So here this whole part is 1. So that means limit h tends to 0. Which term is left? 2 into x plus h plus 3 root over 1 minus twice x plus 3 whole square, then minus twice x plus 3, then root over 1 minus 2 into x plus h plus 3 whole square, whole by h. Only this term is left. The sin x inverse expression is excluded by using the formula here. So here you can see in the numerator part the root over terms is coming. So which concept that you have regarding the root over terms? If you have any root over expression in the denominator as well as in the numerator, then what should be our next step and what should be the next process actually? Okay, so if you have any root over expression, wherever it is, you should use the rationalization method. Rationalization method means you have to multiply by the same expression, whatever you have, presently, whatever you have, this expression should be multiplied, but the minus sign is there, but the conjugate term will be, the plus sign will be the middle. Okay, the same term, the whole expression will be same, but the sign will be changed. In the middle, if you have the minus sign, then you should multiply by the term where the plus sign will be in the middle. Okay, so that's why. Okay, so now limit h tends to 0, 2 into x plus h plus 3 root over 1 plus twice x plus 3 whole square minus 2x plus 3, very long expression is, okay, it is not actually, it is going out of the board. Okay, so 2 into x plus h plus 3 whole square. So this is the main expression. Now you have to multiply with the conjugate. Okay, so just actually this space is not so enough for getting the solution as well. Just we are using the shortcut process here. Shortcut means just we are taking the jump. Jump means here, if you are introducing the conjugate in the numerator part, then I think in the numerator a plus b, a minus b formation will be created. Okay, so a plus b, a minus b, that's why a square minus b square will be there. That is, this will be whole square and this will be whole square. And in the denominator part, the expression actually, the plus sign will be the middle. That is 2 into x plus h plus 3, and here 1 minus 2x plus 3 whole square minus 2x plus 3, 1 minus 2 into x plus h plus 3 whole square. Okay, just we had multiplied the numerator as well as the denominator by the conjugate term as well. So in the numerator part, I think a square minus b square expression is introduced, actually is being surfaced. So I think a square minus b square, if you have the square on any root term, then I think this root actually will be excluded. Root और square cancel हो जाता है ना, तो that means यहाँ पर देखो limit h tends to 0, ऊपर क्या होता है, root और square cancel कर दो, क्या निकलता है 2 into x plus h plus 3, और ब्रैकेट में क्या रहता है 1 plus 2x plus 3, है कि नहीं? ठीक है, हो गया. तो ये होल स्क्वायर भी एक है, होल स्क्वायर एक है, ठीक है, और इधर माइनस ट्वाइस एक्स प्लस 3, और उधर रूट चला जाएगा 1 माइनस 2 इंटू एक्स प्लस एच प्लस 3 होल स्क्वायर, होल बाई h into just sorry, this will be plus, this will be plus. Now you can see the in the denominator part, this term you have. Okay, if you use h equals to 0 only on this expression, not on this, remember this thing, because if you are putting h equals to 0 here, then the whole expression will be undefined. That means we can't put h equals to 0 in this place, but in this place we can. We can, because this expression will not be 0 and the whole denominator part will not be 0. That means the answer will not be undefined. Okay, so here h equals to 0 we can put. If you put h equals to 0 here, h equals to 0, here h equals to 0, then what will be there? Just you can see, twice x plus 3 and then root 1 minus twice x plus 3 whole square plus twice x plus 3, then root here also 1 minus twice x plus 3 whole square. You know, there is no h, but the expression is actually is not equals to 0. This middle में प्लस है तो 0 तो कभी नहीं होगा. अब दोनों के अंदर प्लस होके ऐसे लिख लो डायरेक्ट 2 into 2x plus 3 then root 1 minus 2x plus 3 whole square. Okay, and limit h tends to 0. ऊपर जो है, ऊपर क्या करेंगे अभी, यही क्वेश्चन है ना, ऊपर क्या करेंगे? नाउ एक काम करो, यहां पर ये माइनस है, ये माइनस है, ठीक है. x इंटू रूट ओवर 1 माइनस वाई स्क्वायर माइनस होगा, तो यहाँ पर ये जो है माइनस होगा. जस्ट फॉर्मूला देखो, फॉर्मूला में देखो माइनस है, ठीक है. अब जो है हम लोग यहाँ पर और होल स्क्वायर है ना, तो देखिए ये भी स्क्वायर हो जाएगा क्योंकि इसके ऊपर रूट है, तो इसलिए रूट और स्क्वायर कैंसिल हो जाएगा. बट इसके ऊपर तो रूट नहीं है ना, तो इसके ऊपर तो स्क्वायर आएगा, इसके ऊपर भी आएगा, इसके ऊपर भी आएगा. तो देखो ऐसा आ गया, ठीक है. अब जो है हम लोग मल्टीप्लाई शुरू करते हैं. मल्टीप्लाई कैसे करेंगे? देखो थोड़ा शॉर्टकट, थोड़ा दिमाग यूज करना पड़ेगा. यहाँ पर थोरोली आपको मल्टीप्लाई नहीं करना है. देखो ये स्क्वायर दिस होल एक्सप्रेशन इंटू 1, दैट इज दिस पार्ट, माइनस 2x plus 3 whole square इंटू 2 into x plus h plus 3 whole square. ये पूरा एक्सप्रेशन दिस इंटू 1, दिस इंटू दिस, माइनस अगेन 2x plus 3 whole square, then minus minus plus 2x plus 3 whole square, and then 1 minus 2 into 2 into x plus h plus 3 whole square. Okay, 2x plus 3 whole square and this one not minus equal to whole square. Okay, so in the denominator part h is there. Now I think this part and this part will be cancelled. Okay, now which term is left? 2 into twice x plus 3 root over 1 minus twice x plus 3 whole square, limit h tends to 0, limit h tends to 0, 2 into x plus h, just write 2x plus twice h plus 3 whole square minus twice x plus 3 whole square by h. Agree? So that means ये जो है वो तो सेम ही रहेगा, twice x plus 3 रूट ओवर 1 minus twice x plus 3 whole square. है कि नहीं बच्चों? ठीक है, तो लिमिट h tends to 0. यहाँ पर देखो a square minus b square, a plus b, a minus b, twice x plus twice h plus 3 plus twice x plus 3, a plus b, a minus b, twice x plus twice h plus 3 minus twice x minus 3 whole by h. ओके, सो दैट मीन्स यहां पर देखो कैंसिल होता है कुछ इसमें, इसमें शायद होता है, देखो 2x कैंसिल, 3 भी कैंसिल हो जाता है, ठीक है. और ये जो h है ना, ट्वाइस h बाकी रह गया, यहाँ पर h ये भी कैंसिल हो जाएगा, है कि नहीं. तो नेक्स्ट लाइन में देखो थोड़ा बहुत सिंपल हो गया है यहाँ पर. नाउ इन द नेक्स्ट पार्ट solution is about to complete now. So 1 by 2 twice x plus 3 root over 1 minus twice x plus 3 whole square. Limit h tends to 0. Here twice x 4x, 4x plus twice h plus 6 by h into twice h. यहाँ पर h कैंसिल. बस अब जो है न्यूमरेटर में तो है ही नहीं कुछ. डायरेक्टली यू कैन पुट द लिमिट हियर. डायरेक्टली यू कैन पुट द लिमिट नाउ. 1 minus twice x plus 3 whole square, and just you can put the limit here. H equals to 0. That I think 4x plus 6. So this is and 2 is also there. 2 is also there, and this 2 will be cancelled. That means this 2 will not be there. That means ultimate answer will be 4x plus 6 by 2x plus 3, and then root 1 minus 2x plus 3 whole square. This is the final answer. Very long calculation. Okay, very long calculation is okay, but calculation is simple. Calculation is simple. This type of questions were done in the different lectures as well. Okay, just we have used the differentiability, this first principle concept, for solving different types of functions. But here this function is actually is complicated, and that's why the solutions is becoming very much lengthy and very clumsy also. But the calculation is same, just like your seems like your previous solutions. Okay, now we are going to solve the direct questions from the differentiation as well. Okay, हम लोग कुछ डायरेक्ट क्वेश्चन करते हैं डिफरेंशिएशन से. ये तो फर्स्ट प्रिंसिपल हो गया. अब इन द क्वेश्चन इन द एग्जाम this question will be given, the find the differentiation of this using first principle. Then you should use the first principle. Other than that, you should use the normal process. And the normal process is what? How can I use the normal process here? In the class 11, I think you solved the different differentiation questions. So here also we are going to solve the direct questions as well. हम लोग डायरेक्ट क्वेश्चन भी सॉल्व करेंगे. ठीक है, कैसे करते हैं पूरा देखो यहाँ पर. सो यहाँ पर देखो, पहला क्वेश्चन जो हम लोगों ने किया है पहला क्वेश्चन log sin x था ना. सो यहाँ पर लिखो y इक्वल्स टू log sin x, y इक्वल्स टू log sin x. ठीक है, जब हम लोग डायरेक्ट क्वेश्चन सॉल्व करेंगे, डायरेक्ट क्वेश्चन सॉल्व, तब हम लोग को देखना है ये जो क्वेश्चन दिया हुआ है, इस क्वेश्चन में हाउ मेनी एक्सप्रेशंस आर देयर. How many expressions are there? Expression means this log one expression, sine second expression, x third expression. That means log first expression, sine second expression, and this x will be third expressions. Okay, that means if you have the three expressions, that means 3 times the differentiation should be chosen for this particular question. कैसे? देखो कैसे करते हैं. डिफरेंशिएटिंग विथ रेस्पेक्ट टू एक्स. एक्स के रेस्पेक्ट में हम लोग डिफरेंशिएट कर रहे हैं, तो कैसे लिखते हैं? एक्स के रेस्पेक्ट में डी डी एक्स लिखते हैं, बोले थे ना हम लोग. ऑफ वाई, वाई का डिफरेंशिएशन कर रहे हैं. सो डी डी एक्स ऑफ लॉग साइन एक्स. नाउ सी द फॉर्मूला. ddx ऑफ log x का फॉर्मूला क्या होता है? ddx ऑफ log x का फॉर्मूला क्या होता है? 1 by x है क्या नहीं? सो दैट मींस यहाँ पर देखो ddx ऑफ log x, x के जगह में यहाँ पर क्या है? sin x है. दैट मींस आपको क्या लिखना है? 1 by x लिखना है या फिर 1 by sin x लिखना है? 1 by sin x लिखना है. गया, log का डिफरेंशिएशन खत्म. फिर उसके बाद किसका आएगा? ddx ऑफ सेकेंड एक्सप्रेशन क्या है? sin है क्या नहीं? ठीक है. So that means 1 by sin x तो लिख लिया. अब ddx of sin x हम लोगों ने फॉर्मूला लिखा था. ddx of sin x क्या होता है? cos x होता है. तो ddx of sin x cos x होगा. गया, sin का भी चला गया डिफरेंशिएशन. लास्ट एक्सप्रेशन दैट मींस थर्ड एक्सप्रेशन क्या है? x. ddx of x, ddx of x तो क्या होता है? 1 होता है ना. तो cos x by sin x क्या होता है? cot x. दैट मींस ddx of y, इसको हम लोग लिख सकते हैं dy by dx, dy by dx, ddx ऑफ y. दैट मींस यहाँ पर y वेरिएबल का डिफरेंशिएशन हो रहा है x के रेस्पेक्ट में. y वेरिएबल का डिफरेंशिएशन हो रहा है x के रेस्पेक्ट में, तो हम लोग क्या करेंगे? dy by dx डायरेक्ट लिख देंगे उसको. ठीक है, This is a ddx of z, that means dz by dx. ddx of p, that means dp by dx directly. But ddx of x, answer is 1, because function is x, differentiating with respect to x, तो answer is what? That means यहाँ पर x हम लोग स्टाइल करके लिखते हैं तो dx by dx होता है ना, तो dx dx कैंसिल हो तो 1 होता है ना आंसर. तो यहाँ पर देखो कैंसिल नहीं होता है, इसलिए जैसा है वैसे ही रह गया, dp by dx है कि नहीं है. सो ये देखो यहाँ पर सिंपल, वो देखो कितना बड़ा कैलकुलेशन करके आंसर पोटेक्स आया था फर्स्ट प्रिंसिपल यूज करके. यहाँ पर देखो नॉर्मली 3 लाइन में आंसर आ गया है कि नहीं है. फिर हम लोग देखो सपोज y इक्वल्स टू e टू द पावर साइन एक्स स्क्वायर है, ये क्वेश्चन सॉल्व करते हैं. तो यहां पर देखो हाउ मेनी एक्सप्रेशंस आर देयर. दिस इज योर फर्स्ट एक्सप्रेशन, साइन इज द सेकंड एक्सप्रेशन, एक्स स्क्वायर इज द थर्ड एक्सप्रेशन. 3 expressions are there. Okay, so if you have the 3 expressions, that means 3 times differentiation should be taken. Here also 3 times differentiation was taken, that you can see the first time differentiation, second time differentiation, third time differentiation. 3 differentiation were chosen in the last question. Here also the 3 expressions are there, that means you should have chosen the 3 differentiation at the stretch. So ddx of y, so ddx of e to the power sine x square. So as you all know, ddx of e to the power x according to the formula क्या है, ddx of e to the power x का e to the power x ही होता है. So e to the power x, x के जगह यहाँ पर क्या है sin x square, तो आपको भी e to the power x लिखना है या फिर sin x square लिखना है, sin x square ही लिखना है कि नहीं. x के जगह यहाँ पर जो होगा आपको वही लिखना है ना. फॉर्मूला है यहाँ पर x है, तब x की जगह तो यहाँ पर तो sin x square है, तो आपको तो sin x square ही लिखना है. गया यहाँ पर एक्सपोनेंशियल का डिफरेंशिएशन, e का चला गया. फिर उसके बाद सेकंड एक्सप्रेशन क्या है, sin. तो ddx of sin x square, that means for which term is espoused with the sin expression as well, that should be differentiated. Here x square is espoused, is attached with the sin expression, then sin x square, the whole part should be differentiated. Okay, so e to the power sine x square. So ddx of sine x, ddx of sine x means cos x, x तो यहाँ पर x square है, तो आपको भी x square ही लिखना है. Now it's time to differentiate the third expression now. So ddx of x square, it is your third expression. So e to the power sine x square into cos x square. So cos x square, and ddx of x square means what? If you have the square or the power on one particular variable, then you should use the formula ddx of x to the power n. Okay, so n x to the power n minus 1. ओके, कांस्टेंट पावर होना चाहिए. कांस्टेंट पावर जब होगा तभी ये फॉर्मूला यूज करोगे, याद रखना. कांस्टेंट पावर जब होगा तभी तुम ये फॉर्मूला यूज करोगे. रिमेंबर दिस थिंग. हाँ, कांस्टेंट के बिना यहाँ पर कुछ भी वेरिएबल पावर है, देन वी कांट यूज दिस फॉर्मूला हियर. ओके, जस्ट इफ यू वांट टू यूज दिस फॉर्मूला, देन द पावर शुड बी इन द कांस्टेंट फॉर्म. ओके, so here you can see x square, that is nx to the power n minus 1, 2 into x to the power 2 minus 1, that is twice x e to the power sin x square into cos x square. Okay, now similarly just we can choose the different questions from our mind as well. Okay, so just y equals to log sine 10 e to the power root x. Now you can see the long expression is there. Now you have to count how many expressions are given in this question. Log first expression, sine second expression, 10 third expression, e fourth expression, root x fifth expression. Okay, fifth expression. So ddx of, that means 5 times. Here also देखो 1 time, 2 time, 3 time. 3 बार हुआ ना डिफरेंशिएशन, 3 एक्सप्रेशन था. यहाँ पर 5 expressions will be given. Is given. Just you should differentiate the whole expression by taking the 5 times differentiation as well. So here ddx of y equals to ddx of log sine 10 e to the power root x. Okay. Now at first, what is your first expression here? Log x. Whole thing is x. Log x. Dx of log x. Formula is what? 1 by x. This whole term x. So there is 1 by x. That is sine 10 e to the power root x. Log expression complete. Now sine. Dx of sine 10 e to the power root x. So here sine 10 e to the power root x, dx of sine this, that means sine x, cos x होगा. So that means cos x के जगह में आपको क्या लिखना है? 10 e to the power root x. That means whatever the term is replaced, x is replacing x, that term should be written in this part. So sine x, cos x. Now sine expression is completed. After this sine के बाद क्या आएगा? 10. dx of 10 क्या है? 10 e to the power root x. So यहाँ पर देखो cos this by sin this, उसको cot लिख सकते हैं. Cot 10 e to the power root x. dx of 10 this, that means dx of 10x का फॉर्मूला क्या होता है? देखो फॉर्मूला में sec square x होता है. That means sec square x के जगह में तो ये है e to the power root x. आप भी वही लिखेंगे. 10 का खत्म. 10 के बाद कौन सा एक्सप्रेशन आया? e का. That means dx of e to the power root x. Agree? ठीक है? So now cot 10 e to the power root x, then sec square e to the power root x. Now e to the power root x differentiation is e to the power x differentiation is e to the power x ही होता है. Agree? तो यहाँ पर x के जगह देखो यहाँ पर क्या है? रूट x है. तो रूट x है ना, तो आपको भी यही लिखना है. फिर लास्ट एक्सप्रेशन क्या है? रूट x dx of x. Now cot 10 e to the power root x, sec square e to the power root x, e to the power root x, and dx of root x means half x to the power half minus 1. That is cot 10 e to the power root x, sec square e to the power root x, e to the power root x, then half 1 by root x is the answer. This is the answer actually. Okay. So here you can see the various questions and various this expression and this expression related questions. Okay, just in the normal videos, in the normal lectures, just you will never see this type of explanation, this expression type differentiation. Everywhere the word will be used and there is the chain rule. Okay, this expression choosing is called the chain rule. Okay, so that means by using this chain rule, that means one after that we are using the differentiation here. So this is the chain actually. We are differentiating term by term. Okay, so इसको बोला जाता है चेन रूल. तो चेन रूल हम लोगों ने यहाँ पर ये वर्ड यूज ही नहीं किया. अगर यूज करता तो यहाँ पर कंफ्यूज हो जाता है, ये चेन रूल क्या है क्या नहीं. No need. Okay, no need to just you have to remember all the concepts and all the things according to your mind. That means whatever the things are being actually accepted by your mind, that should be remembered like that. Okay, so you should remember this type of calculations, this type of differentiations like that. I think it will be easier. Okay, just expression division, just in the various lectures that you can see in the various lectures in the various books, you will never experience this type of explanation, the experience type the expression type differentiation. Okay, so in this video just we have to stop here, and this is actually the basic structure of the differentiation. Actually this according to the different lectures we will move to the next phase. This is the basic phase, and after that we will move to the middle level phase. And actually this type of questions are very important also. Okay, actually this type of questions may be given from the examiner's mind also. That means they make it, no problem. Okay, so this type of questions actually are supposed to be given. Actually it is not sure. Okay, so Whenever this type of questions will be given, just you have to split the expressions here, then one by one, according to the given expressions, you have to remember where we should use the differentiation here. Okay, now if you like my lectures, if you like my videos as well, please subscribe, like and share my channel as well. Okay, so thank you very much for watching my channel, and just stay healthy, stay safe, and stay at home as well, and don't be infected by this deadly virus also. So bye and Jai Hind.